your textbook also. This one's a little different. The only difference is this one is like a side-by-side table instead of just a vertical table. So if you're looking at these, the first one is acetate, and it gives you the formula. Carbonate, hydrogen carbonate, hydroxide nitrite is NO2 minus, nitrate is NO3 minus. So ite means less oxygen and ate means more oxygen. Then we have chromate, dichromate, phosphate, hydrogen phosphate, dihydrogen phosphate, ammonium. And then we get into the hypo and the pers. So if you look at the stuff at the top on the right-hand side, you'll see the name is hypochlorite. And it has the formula ClO minus. And then chlorite, ClO2 minus. Chlorate, ClO3 minus. And perchlorate, ClO4 minus. So what is the pattern that we're seeing there in the formula? Yes, hypo is where there's less oxygen. So the pattern is that in the formula, the oxygen keeps increasing. So it goes from 1 oxygen to 2 oxygen, then 3, then 4, and so forth. Yes, hypo is the least and per is the most. You can kind of remember that hypo is the least. If you think about hypoglycemia, it means that you don't have enough blood sugar. Your blood sugar is low. And then per meaning more. You can kind of remember that from hyperactive, meaning that you have extra energy. Yeah, hypothermia, not enough heat. And hyperthermia, you have too much. And it's not necessarily saying that per means for oxygen. It just means that there are more of them. So the only time this would be really useful is if you were given some sort of a matching question, and maybe they gave you the 4 names and the 4 formulas, and you had to match them up. Then you could match them up knowing that the one with the least amount of oxygen was hypo, and the one with the most oxygen was per, and then the one with slightly less was chlorite, and the one with slightly more was chlorate. Yes, it depends on the polyatomic ion. Let's see, because if you look at chlorate is ClO3 minus, but if you look down below that, you'll see sulfite, and that's SO3 2 minus. So ite doesn't mean 3 oxygen, it just means less oxygen. The other one they've got there with sulfur in it is with an oxygen in it is sulfate, so it's like 2 down, SO4 2 minus. Yeah, so with these, probably the easiest way to memorize them, there are 2 things you need to be able to do. One is be able to recognize them. And so that would be like flashcards. Recognize them and name them. And the next thing is, given the name, be able to write them down. So you want to do some practice with like a flashcard that says acetate, then you write it on a piece of paper, flip it over, and see if you wrote it correctly. So that helps. It takes a little while, but if you practice, I'd say if you practice probably 15 minutes in the morning and 15 minutes at night during the week, you probably have those done in a couple of days, most likely. Yes, sometimes I do teach Gen Chem too. Arib, is this overwhelming? A little bit. It's not so bad once you get practicing. Yeah, and I'll have all of the rules on D2L. We'll see. I might be able to teach it. It kind of depends on what they give me. So let's see. I'm going to stop sharing this and go back to show you what I've got on D2L for you. All right. So after that, I've got naming acids. So it gives you basically some examples of some acids that are named on the left. And then it also shows you how to name a base, which naming bases are really easy. Pretty much all of the bases that you're going to run across have hydroxide in them. So it's just the name of the metal, then hydroxide. The only one that I really know of that I can think of off the top of my head that doesn't have a metal in it is ammonia. All right, so here's the question that you ask yourself with an acid. How many elements are in it? If it's only 2, then you follow the binary acid naming rules. If it has oxygen in it, then you follow the oxyacid rule. When I say 2 elements, I don't mean like that CO2 would be considered 3 elements because there are 2 oxygen. I mean that carbon is 1 oxygen, oxygen would be a second one. So if that makes any sense. Say, how much of this topic will cover our test? Just a regular, like if you take all of the sections that we're going to cover in chapter 4 and you, like, let's say there are 8 sections, then that would mean this is probably 1/8 of the test. So, correct, Erin, two different ones. So Tiana, you were asking, so those are the ones we memorized. Do you mean the acids I was showing just a second ago, or are you talking about the polyatomic names and formulas? Yeah, let me show you where you can find it in your textbook and what it looks like in your textbook so you can kind of see what to look for. There we go. Oh, no, that's not what I'm supposed to be showing. Not what I meant to show. Do you even have your textbook up? Yes, okay. There it is. Okay, there we go. Okay, so with the Norton textbook, our textbook, it gives you the same information. It's just not as visual. And that's why I pulled a lot of stuff out of the other textbook and put it on D2L so that you have the visual stuff if visual works better for you. So it's got the rules for naming binary molecular compounds, and then it's got what the prefixes are in table 4.3. And it's got a little bit of information to the right. It gives you a couple examples. And then it talks about binary ionic compounds. So that would be like sodium chloride and things like that. And then binary ionic compounds of transition metals. It would be transition metals, transition metals, tin and lead. Tin is Sn and lead is Pb. So it gives you that information. And then it gives you, this is what your list of polyatomic ions looks like in your textbook. So it's basically the same ones as in the other book that I just showed you. It's just, it looks like more because the other table is side by side and this one is just vertical. I also have a list of polyatomic ions for you to memorize that's on D2L. It's not like more polyatomic ions. It just gives you, a different list. So it's, but if you memorize this table here, you should pretty much have everything you need. Let me see if there's anything missing. Ammonium is there. Chlorate, perchlorate. I think that's pretty much everything. You're welcome. All right, so let's look at, class is over. It's 11. That was fast. All right, so I was just going to look at some examples. So that's pretty much all the information you need that you should need for the homework. I'll take a look at it and see if there are any weird things in there. If there are, send out an email telling you how to do it. The information I was showing you that's not showing up for everybody, right, is going to be up this afternoon because I got one more class to teach before I can do that. But as soon as I do that, then it'll be up. It should be a PDF, so that it should show up a lot easier. You're welcome. You guys have a good afternoon. I will be available during office hours if you need. If not, I will see you on Monday. And don't forget, you have homework due on Sunday.
Professor, I have a question. Hello?
She left.